Here we have the function sine of x, which is the trigonometric function, and we want to find the derivative of sine of x. And so this is definition of derivative. Derivative of f of x is the limit of f of x plus delta x minus f of x dividing by delta x as delta x approaches 0. And so the derivative sine of x, by definition, in the place of x, we would put x plus delta x. So it would be sine of x plus delta x minus sine of x and dividing by delta x. So f of x is sine of x. And so f of x plus delta x will be sine of x plus delta x. And we have these formulas before where the limit of sine of x dividing by x as x approaches 0 is 1. If we replace x with delta x, then we get the same result. So instead of x, we have delta x. And before, we also have limit of 1 minus cosine of x dividing by x is equal to 0. And so we replace x with delta x, and then we get the same thing. And the other way around, 1 minus cosine over x, or cosine minus 1 over x is still 0. And then also from trigonometry, we have these formulas. Sine of a plus b is sine of a cosine of b plus cosine of a sine times sine of b. And cosine of a plus b is cosine of a times cosine of b minus sine of a times sine of b. So instead of a and b, if we have x and delta, then we'll get similar results. So these are identities that we get from trigonometry. And so now back over here, then what we're going to do is we're going to rewrite sine of x plus delta x, sine of x plus delta x with this identity right here. So in the place of sine of x plus delta x, we have this identity right here. And then what we're going to do next is just move some terms around. So what we're going to do is go ahead and put this in the front. So move that to the front and then move this to the middle. So that way we'll have sine and sine right here. And then if we look at these two terms right here, the common factor is sine of x. And so we're going to write it as sine of x times cosine of delta x minus 1. Common factor is sine of x. And so we factor out the sine of x, then what's left is cosine of delta x minus 1. And again, if we multiply here, we do sine of x times cosine delta x, and this is what we get. And if we do sine of x times minus 1, then we get minus sine of x. And then we're going to write this like this. We're going to split this right here. This is, the top here is the sum of this expression and that expression. So we'll go ahead and split them up into the sum of two expressions like this. And so, and then now we're going to move this cosine of x right here, move that to the front here, and then move this sine of x to the front. And recall that limit of sum is just sum of limits, and then limit of product is just product of limits. And so this will be the same as this. This is the limit of cosine of x as delta x approaches 0, and so there's no cosine, there's no delta x here. And so we just get cosine of x. This is the limit of sine of delta x dividing by delta x as delta x approaches 0, and we got this formula right here, which is 1. And this is the limit of sine of x as delta x approaches 0, and there's no delta x here, so we just get sine of x. And this is the limit of cosine of delta x minus 1 dividing by delta x, which is this formula right here, and we get 0. So we end up with cosine of x. So what that says is that the derivative of sine of x is cosine of x. And now let's do the derivative, so we did derivative sine of x, now let's do the derivative of cosine of x. So we want the derivative, the cosine of x, so we're going to do similar to what we did earlier. So the derivative of cosine of x was going to be cosine of x plus delta x minus cosine of x. Copy the formula right here. Again, this is the definition of derivative, and so we have cosine of x, and in the place of x, we would put cosine of x plus delta x. And so again, we're going to use this formula right here. In the place of cosine of x plus delta x, we have the identity cosine of x times cosine of delta x minus sine of x times sine of delta x. So in the place of cosine of x delta x, we'll replace it with this identity. And then we're going to arrange the terms here. So we'll move this to the back. And if we look at these two terms right here, the common factor is cosine of x. So we have cosine of x, and then minus 1. So once again, the common factor here is cosine of x, so we have cosine now in front, and then we have cosine of delta x minus 1. And then we're going to separate the difference here. So that's going to be the same as this, minus that dividing by delta x. And then we're going to move some terms around. So this is the same as if we write it as cosine times this quantity, and then this is sine times that quantity. And once again, the limit of the difference is difference of limit, and limit of product is product of limits. So which means we can put the limit in front of each term here. So this is the same if we write it like this. Limit of cosine of x with delta x going to 0, but there's no delta x here. And so we're just going to get cosine of x times limit of cosine of delta x minus 1 dividing by delta x as delta x approaches 0 is 0. This is the limit of sine of x as delta x approaches 0, but there's no delta x here. And so we just can get sine of x. And this is the limit of sine of delta x dividing by delta x as delta x approaches 0. And for that, we're using this formula right here, which is 1. So final answer is negative sine of x. So the derivative is equal to negative sine of x. So the derivative sine of x is cosine of x, but the derivative cosine of x is negative sine of x. And now we want to find the derivative tangent of x. So we just did the derivative sine of x, which is cosine of x, and we did derivative cosine of x, which is negative sine of x. Now we want to do the derivative of the tangent of x. And for the tangent of x, we're going to need the quotient rule for derivative. And once again, the quotient rule is derivative of quotient, like f of x divided by g of x, is going to be g of x times the derivative f of x minus f of x times the derivative g of x, and then divided by g of x squared. So we want the derivative of tangent of x. Recall from trigonometry that tangent of x is sine of x dividing by cosine of x. And now we have the quotient. Sine of x is like f of x, and cosine of x is like g of x. And we're just going to use this formula right here. So we have cosine of x times the derivative of sine of x, which is, and then minus sine of x, and times the derivative of cosine of x, and then divided by cosine of x squared. So we have cosine of x, and we just did this one. The derivative of sine of x is cosine of x. And then this is sine of x. The derivative of cosine of x is negative sine of x. And then the bottom here, we just have cosine of x squared. This is cosine of x times cosine of x. So we have cosine of x squared. And then minus this should be negative. Negative and negative becomes a plus. And sine of x times sine of x is sine squared of x. And recall from trigonometry that cosine squared of x plus sine squared of x is 1. So let's put that down. So from trigonometry we have this identity, cosine squared plus sine squared is 1. And then also recall that secant of x is 1 over cosine of x. And so what it means is that secant squared of x is equal to 1 over cosine squared of x. For the cosine of x, we can write it this way, or we can write it this way. It's the same thing. So 1 over cosine squared of x is equal to secant squared of x. So the derivative of tangent of x is secant squared of x. So summary, so this is what we have so far. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And the derivative of the tangent of x is secant squared of x.